All right, welcome everyone. Thank you for joining us for another Android Developer Lab Plus. Uh, we didn't run the episode last week, but we are here today, and today's topic is actually in-app billing. But before I go ahead with introducing the topic, let's see who else has joined us live. So firstly, Anirudh.
Hi guys, I'm Anirudh and I'm based out of Hyderabad.
Hi, I am Tony Chan. I'm based out of Hong Kong.
And I am Ankur Cotwell, and I'm coming to you live from Sydney. So let's get started with this. The first section we have is news, and Tony's going to introduce it.
Sure. So the first news we have this week is, can we jump to the next slide, please?
Sure.
Yep. So we have a new preview number 4 for our Android developer tools. There is no new feature, but there are a lot of bug fixes in this release. The second news I want to talk about is we now published the app template documentations. So I think we need to jump to the next bullets to show the short link. So basically, we introduced earlier something called application templates. So it's a tool for developer to easily get started like building Android applications, and we want to share this actually with developers so that you can build your own templates. And so we have some template guidelines or format in order to build your own, and it's covered in one of a Google Plus post by our colleague Roman Lurik, and the short link is here. So the third news I want to mention is we're going to have an event in Hong Kong. It's a GDG Google Developer Group event in Hong Kong coming up on the 24th. It's in the evening in the Kowloon side of Hong Kong in the Inno Center. So the details you can find in this short link, and we have and that night I will be there, and also Ankur and Jan Felix. We three of us will be speaking on Android in different topics. So hopefully, if you are in Hong Kong or you're based in Hong Kong, we look forward to seeing you on 24th. Thanks.
Thanks, Tony. So yeah, we're looking forward to meeting those developers in Hong Kong. Last week or earlier this week, we got to meet some developers in Korea, and that was a really great experience. So we're looking forward to seeing more developers in Hong Kong, Tony and myself. So today's topic, as I mentioned, is in-app billing. So in-app billing is something we introduced last year, and it's really taken the market by storm. Back then it was called Android Market, but it's proven to be a very successful business model for a lot of apps. So it's really enabled the freemium model, where the app itself is free, and your users can get a taste for the type of experience or utility that your app provides, and then they can choose to pay for more of whatever it is that you're selling in your app. So don't just think about it from a games point of view. It's also a great migration path to convert free users to paid users. So the old model of offering a light version or a pro version, it's still valid, but really in-app billing makes it even better, because you don't need to have two different app listings. You can have a single one. Users can pay for the one upgrade and continue their experience from within your app itself. Often when you upgrade from a light to pro, the user has to go and download the pro version. They end up with two different versions of your app on their device, and you have to do some extra work to convert whatever data you had from the free version into the paid version. So in-app billing really enables that paid model very well. So today we wanted to talk about, well, how do you go about implementing in-app billing? Then we'd love to hear some questions. So just an overview. With in-app billing, there's really two types of items that you can have. One are managed items, and these are typically things that you only buy once, and we'll talk about the details of these. And we have unmanaged items as well. Now, when it comes to the implementation side of it, there's actually, you can do an in-app billing implementation that's entirely client-side, or you can have a version of it where you've got some of that data stored on your server. And we're going to look at how that process varies between the two and what advantages and disadvantages we can have. So, managed items. These are typically, as I mentioned, items that you only buy once. So, if you have a book or an app that's like a book, you might have some episodic content where you provide chapter 1 of that app or that content for free, and then users can pay to unlock chapter 2 and then chapter 3 and so on. And in the case of a game, it might not be chapters, it could be levels, it could be characters, and so on and so forth. Now, one of the features that we have in in-app billing is that your app, can actually ask to replay transactions. Now, this sort of thing is useful for users that kind of install the app on multiple devices, and you want to make sure those purchases transfer across. But there can be times where if you found some gray areas in your logic where, for some reason, that transaction, even though it was successful, your app hasn't picked it up. You've got this option to replay transactions and restore the user's purchases effectively. So managed items are really great. They're called managed items because we allow you to be able to replay them, and we track them for you server side. The next type of items are unmanaged items. And these are not typically the type of items that you only consume or purchase once. So in the case of a game, it might be some in-game coins. So you want to allow the user to purchase these coin packs more than once. Or it could be potions, whatever. In the case of an app or a service that you're providing, you could also do something like ask the user to pay X amount of money every month or every year. Today I wouldn't actually use in-app billing for that recurring payment because we actually have subscription billing, which is very similar to in-app billing, but it automatically recurs for your refreshes. So subscription billing is a separate topic, but I guess the aim of this slide is talking about unmanaged items. Now, because they're unmanaged items, it means that we, as in Google Play, don't manage them for you. You can't ask to have them replayed. So you need to keep track of this state information yourself. And this is where some of that server-side implementation may actually help you. All right, so let's go to the next slide. This here is a flowchart, and what we want to show you is kind of flow that you get from your application and how those requests and responses work. So the top half of the screen is the Google Play server, and then everything below that dotted line is really the device itself. Now, for in-app billing, there's two critical components. One is your app. The other part is the Google Play client. And we're going to see how the Google Play client is really involved here. So what happens is, in terms of how we secure this data, we actually have your app will have a public key that you generate. The Play server has the private key. Now, from your app, what you do is you use your billing service to make a billing request. And your app is actually, when you make that billing request, it's making it locally on the device to start with. It goes to the Google Play client. The Google Play client then actually forwards on that billing request to the Google Play server, where it's processed, and the users have an opportunity to, say, hey, I want to pay for it using this credit card, or if they've bought an Nexus 7, they might have some credit left over, so they may choose that purchasing option. But anyway, so it's processed at the Google Play server side, and then we get a response that's signed by the Google Play server with that private key we talked about. That response is passed back to the Google Play client, which in turn passes the response back to your app, to your billing receiver component. You then use that public key to decrypt that message and process it how you want. So that's basically telling you, hey, the purchase succeeded, or occasionally it may even tell you things like the purchase failed. And there are a number of failure states that you do need to take care of. For example, the user's credit card may not have had the funds, or the purchase may have been declined for whatever reason. We have extensive documentation on those scenarios that you need to support on developer.android.com. But this is the client version, and you can see it's fairly straightforward when we look at it step by step. Let's now talk about a version of this where we introduce your own server. So you'll see now we have two dotted lines. So above the topmost dotted line, we have the Google Play server. And in the middle there, in between the two dotted lines, is the device. We have the Google Play client and your app. And then below the dotted line, we have your server. Now you'll notice that the public key is no longer sitting in your app itself. It's now sitting on your server. So that's where we're going to use it. So let's now look at the flow of how this part of it works. The app will make the billing request, which gets forwarded onto the Google Play server. The Google Play server will respond and sign it with the private key. And then that signed response will actually be passed back to your app, to its billing receiver. So far, it's actually the same as that client-side version. But this is where it differs. Your app will then take that whatever credentials it has and pass it to your server, including that sort of signed response. So let's do a deep dive into what that part of it is, the your app to the your server side. So what happens is your server takes those credentials and returns back a session token to your client. It's obviously utilized that public key, or it will do so. So we take that session token into your app. Your app then requests content with that session token. Now, you should follow the best practices around these session tokens. Make sure they expire after so long. The point of this token is it shouldn't be hard-coded between your app and your server. It should really be used to set up a session every time the client contacts the server. So once you pass that content with that session token, you can then your server can then return the content. Now this is that scenario with the unmanaged items. You can do it this way if you want to track information server side. Now, of course, this is going to work per device because presumably when you add those credentials, you're getting some information from your app. Now, on the server, you may choose to have your own user accounts on where you're tracking them, so that when the users fire up your app, they're basically saying, "Hey, I'm signing in as Bob, and my password is password 123," and then your server is able to track which for that particular identity, what items, unmanaged items have been purchased, and then that way you can restore state easily. So that's the server version of in-app billing. So when you're developing this, you probably want to do a lot of sample testing or prototyping. So what we've implemented are some test IDs that are reserved that you can use to simulate different scenarios. So this is a good way to actually verify your code. If you're using automated unit tests, you can use these product IDs when you make the requests so that you get responses back straight away, and we're simulating the request response here. It's not actually going to go through all of those steps that we talked about. So during development, you'd use this. But there comes a time when you want to actually test with real purchases. So there are a few more steps that you need to do when you're testing real purchases. First, you need to go into your publisher site and register some test accounts. Now, these test accounts are typically any other Google account. So let's say I'm the developer and I'm sitting here and I'm saying, hey, look, we need to add our testers, and Tony and Anirudh are my testers. I would go and grab their email address, register it on the publisher side, so that when Anirudh and Tony make these requests, it knows that these are test accounts. And I'll tell you why it becomes important. What we then need to do is that go and upload our APK to the Play Store, but leave it in an unpublished state. Because right now we're testing it, right? We don't want to publish it and make it available to the world. Then what we do is go and add our products, the in-app purchases that we have. We're going to go and add those to the publisher site. And here is a very important part. You need to go and publish those items there and then. So don't leave those items in an unpublished or draft state, because otherwise your app won't be able to find it. It will say, hey, I didn't recognize this particular item ID. And it's perfectly safe to publish these items because your app has still not been published. So nobody else will be able to make those purchases. In fact, and this is where those test accounts are important, only those test accounts and the publisher account will be able to make those purchases because the app is still unpublished. So publish your items, and you can leave your app unpublished. So once we've added our SKUs or our product list, what we would do is install our app on a real device. You can't use the emulator because the emulator doesn't have the Google Play Store on it. Right? And remember, as we said earlier, you need the Google Play client to actually go and make these purchases. Now, for those test accounts that we talked about, there has to be the primary account on each of those devices that you're testing on. So by primary account, ideally what you want to, primary account, the notion of a primary account has become a little bit fuzzier, but typically it's the first account that you add to a device. Now if you've got some testing devices and there's some other accounts on there, what you would need to do is do a factory reset and then go and add those particular test accounts that you registered on step 1. Then those test accounts can go and use your APK and make purchases. Now these are going to be real purchases, right? We're going to go through the whole process of actually billing those credit cards when you make these purchases. So from the publisher side, you need to go and manually refund those purchases when you're finished testing. That part is really important. If you don't go ahead and refund your test purchases, you could rack up pretty large bills. So it is your responsibility to go and manually refund those by the publisher side. So that's it. During the testing phase, you're actually exercising the full end-to-end purchase mechanism, and we're actually getting responses, and we're making requests to the Google Play client and getting them back from the Google Play server as well. So you're really simulating real-world situations here. It's a great way to...
Arthur, I have one small thing to add on testing. Is so recently we had some issue with testing account set up for building testing, and it was an issue on our end, and it gave some developer impressions. Actually, they cannot test building with test account. But it's actually it was an issue earlier, and that should be fixed now. So so testing with test account should be working now.
Okay, great. No, that's a good point, Tony. Yeah, this was something over the last couple of weeks, but we believe it's been resolved. So if you've had some issues, it should be fixed now. If it isn't, please do raise a...
Let us know, yeah.
Okay, so that's a really high-level overview of in-app billing. We today wanted to just introduce the concept. We know plenty of developers that are using the and in-app billing has been very successful on Google Play. So we think that more developers should adopt the use of in-app purchases or in-app billing because it does at the end of the day provide a really nice user experience. So with that, let's take some questions. We don't actually have anyone live on the Hangout today, so if there's people that can post on the thread, in the Hangouts on Air thread that's on the Google Plus stream, that would be great. If not, let's move to Google Moderator, and I'll hand it over to Anirudh.
I would just like to add something to the presentation here. Some developers have asked me about support in different countries for in-app billing, and because we use the same wallet infrastructure behind the scenes, it's pretty much the same support as the seller support for paid apps. So that's one of the considerations for in-app billing.
Okay, do we want to bring up the moderator thread?
Yes. So the first question there is, and this is from Ian, Orange, California. The first question is, I'd like to use in-app billing for donations. Is this an appropriate use, or would you recommend using an external system? Tony, would you like to take that up? Tony, we cannot hear you.
Sorry. So for in-app billing, for donation, so we don't have any like special policy to prevent developer using in-app billing for donation. But one thing you need to keep in mind is so for donation using Google Wallet it's just like regular how you use Google Checkout Wallet in the past, like for doing for donation, you have to be a verified valid nonprofit organization. In other words, it's a 501c3 or 501c6 organization. So we have a process to verify these organizations, and as long as you satisfy this this criteria, then you can use in-app billing for donation.
Okay, thanks, Tony. So the second question is from Romania, and the question is, most of my clients are requesting a calendar component into their applications. So far, I was using a custom calendar component from a GitHub user. I was wondering if you, I was wondering if you're thinking to release a standard widget which will support this functionality. We do not have a UI widget for calendar built in that you could embed, but starting, I think, ICS, we do have a calendar provider which you can query to get the calendar data and kind of use a widget to put that on your application. Yeah, so anything more you guys would like to add?
No, I guess the calendar widget that we provide for users today, it's part of the AOSP, so Android Open Source Project. So you can certainly go and have a look at the code for that that widget today, and see if you want to build something similar to that yourself.
Thanks, Uncle. Also, if you're using a pre-ICS device or writing for pre-ICS devices, there is a calendar API that's part of the Google API client library, and you could also get user calendar data from there once you authorize using OAuth. So, okay, let's move to the next question, which is again from Romania. Hello. Trying to remove a dialog when coming from back task to front task gives me an illegal state exception. Cannot perform this action after on save instance state. Can you help me on this matter? So this seems like a lifecycle issue. I do not have any specific answer. I do not understand what you're trying to do. So maybe if you have some code trying to remove a dialog. So is this a fragment dialog or a regular progress dialog? Guys, do you have any inputs?
From memory, this sort of issue occurs. It is definitely a lifecycle issue, and it's because some certain code is being invoked out of sequence. Basically, you're relying on. I'm trying to remember what the details are because there's several ways to end up in this, but I think you're trying to rely on the state of certain. It could be a fragment.
So from what I remember, like this exception tends to happen in two places. One is if someone trying to do things in the async task and or trying to update do a fragment transaction when using async tasks or using loaders, because some of these operations can be can still happen actually even the activity go out of the screen, so and past the save instance state. And the framework is very conservative, trying to prevent these kind of states happen even in reality, in most of the time, your activity is still not in that state. So I guess the solution, or I think you really need to look into whether it's proper to update the UI actually in those scenarios, and because the things could happen actually after the activity got recycled or past the safe instance state. So you have to see whether it makes sense actually trying to do some of these UI updates. And one way to avoid the exception, but probably not necessarily the best solution, is to have a flag to keep track of what state you are in, and if your state is not actually in that state, you can do the fragment transaction or things. Otherwise, just skip it, because you're not actually your activity is not actually on the UI anymore. So.
Well, thanks, Tony. So yeah, just look for a lifecycle method before on save instance, probably on pause or somewhere, and you can place your code for removing the dialog there. Depending on whether it's a progress or fragment dialog, you may need to do a fragment transaction. So I think that's it. That's all the questions we had in moderated. So yeah, that kind of brings us to the end of this hangout. Guys, do you have anything more to add?
Yeah, just one last thing. Next week's hangout, we'll just for next week we're changing the day of the week that we're doing it. So only next week we're going to do it on Tuesday. Tony and I will, as we mentioned, we're going to be in Hong Kong on Monday. We're also going to be in Hong Kong on Tuesday. So we'll be running the hangout together in the same location for once from Hong Kong on Tuesday. So stay tuned. We'll make we'll post a new time and a moderator link for you as soon as we can. So with that.
And again, if you happen to be in Hong Kong at that on the 24th, please join us to the GDG event at night on the 24th. So Anke and I and Felix, we will be there, and we're happy to meet with you guys and talk about Android or anything about Google.
Okay, well, thanks everyone for joining, and we will catch you next time.
Thanks.
Bye-bye.